So I'm going to be talking about Ptolemy and the Almagest. So let's get going. So before we talk about his book, we should probably figure out who this guy was. He was born in Egypt, maybe, in 100 AD, maybe, and died in 175 AD, maybe. He was probably a Roman citizen, but we're not sure. One thing we do know for sure is that he worked in Alexandria. So while we don't know a whole lot about his personal life, we do know a whole lot about his book, The Almagest. Almagest means greatest treatise. In Greek, it's not the original name of the book. The original name would have been Mathematical Systematic Treatise, but after being translated so many times, it got changed. So it was written, if you believe his birthday, then it was written through his late 20s to early 40s. So basically it took him 20 years to write this book. You could think of it as Euclid's Elements, but for astronomy. And there's a lot of parallels there. One of them is that we don't know a whole lot about the other books that were written at the time about astronomy, because he essentially destroyed, he obsoleted them. They just stopped copying them after his book was released. It was sort of seen as the standard astronomical textbook for well over a millennium. At the beginning of the book, he kind of gives a sort of purpose for what he's trying to do. And it goes, "We shall try to note down everything which we think we have discovered up to the present time. We shall do this as concisely as possible and in a manner which can be followed by those who have already made some progress in the field." So basically he's trying to do what Euclid did with geometry and mathematics for astronomy. He's basically compiling the knowledge of all the Greece up to that point. So after he talks about what he's going to do, he then talks about how he wants to do it. Basically, he does it really similarly to Euclid's Elements. He starts with some things that they know. He says the observations made by the ancients and in our own times, which are reliable. And then he's going to build proofs off of those to sort of build a model of how the universe works. So he mentions these reliable observations, and he sort of starts off the book by talking about a few kind of axioms that he has that are based on what they had observed up to that point. The axioms basically go like: the heavens move like a sphere, the earth is a sphere, the earth is in the middle of the universe, it has a ratio of a point to the heavens, Earth doesn't move, and celestial bodies have two primary motions. And after he finishes this, he can then sort of start to build off of these and put in his own observations and his own proofs for building out the model of how the universe works. So there are 13 books in the Almagest. It is sort of, each one builds on the last to fill out the model. And the first two books kind of go over some basics, just like the nature of the universe, some trigonometric background that you would need to build onto it, and some observations you can make from about our position on the Earth. He gives some explanations for building sort of viewing devices to measure stars and the sun and the moon and that sort of stuff. And also stuff like the length of daylight, rising times, this sort of basic astronomy stuff. Then in books 3 to 6, he moves on to talk about the sun and the moon. He starts with the sun and then uses that to add the moon to, and discusses sun and moon parallax and eclipse stuff. After that, he spends a couple chapters sort of building off of that, including fixed stars, so that he can sort of bridge the gap between the sun and the moon and the planets. What he is doing is he's using what he knows about the moon to be able to measure where the stars are, and then is using where the stars are to measure where the planets are. So it's kind of like a bridge between these two sections. And then in the rest of the book, he talks about the planets, longitudinal motion, so he can talk about retrogrades, and then planetary latitudes, so he can talk about phases. So one thing that Ptolemy talks about at the end of the book is retrogrades. And he sort of builds out a model for how you could explain retrogrades in the context of a universe where the Earth is in the center. If you look at the picture on the right, or sorry, on the left, it's a compilation of a bunch of images taken over a period of a few weeks or days of the motion of Mars. So I'm going to assume that Mars is coming from the right, but on one day you take the picture and Mars is here, and then the next day it's over here. You're thinking everything's normal because it's moving in a pretty normal way, but then you start to get up here, and all of a sudden Mars seems to just slow down and stop before reversing, and then it goes backwards for a while, and then it reverses again and starts going off this way. And a way that you can explain this motion in a universe with the Earth at the center is you talk about epicycles. Basically, if the planet is orbiting the Earth this way, it's kind of a bad drawing, but in order to explain this sort of backward motion, you can do that by saying, well, it's also kind of coming around this center here in another circle. So over here, if you have this backwards motion, you could say, well, that's just the planet going this way, while it's also at the same time in this part of the epicycle. So it's able to slow down as it's coming, as it's still going around the Earth, and seem to reverse for a brief period of time until you're right about here, which would be this section, where all of a sudden you're speeding up again. So at the beginning of the book, Ptolemy has a little bit of a philosophical introduction where he talks about practical versus theoretical philosophy. It's pretty Aristotelian, I think that's Aristotelian, where he sort of says that you should distinguish theoretical from practical philosophy, and it's important to do so because practical philosophy can allow people to attain a lot of the virtues without having to like intensely study the subject, but theoretical philosophy, you need to be taught to understand it, but often it can lead to practical philosophy that sort of the vast majority of people can use. But he sort of talks about how he has this quote, "Hence we thought it was fitting to devote most of our time to intellectual matters in order to teach theories which are so many and beautiful, and especially those to which the epithet mathematical is particularly applied." So he kind of says, yeah, it's important to have practical stuff, and even if this doesn't end up being practical, it's still beautiful, and it's still like interesting intellectual work to do.
So the Almagest was hugely influential. It started to spread through the Islamic world in the 8th and 9th centuries. We talked a little bit in class about how the Islamic world kind of became stewards of Greek mathematics while the rest of the world forgot it. And this was helped by some Syriac translations, a few Arabic ones, and then by the 12th century they had 5 different translations that we know about. And also by this time the Western world had basically entirely forgotten all about it. There was a translation made to Greek in 1175, but it didn't reach the West fully until the 15th century, and it was obsolete about a century later with the advent of Kepler. And that's all I got. And thanks for watching.